Good deal. In case anybody didn't notice, we will be recording this presentation. That way, anybody who didn't join will be able to upload this to our YouTube channel, and anybody can watch it at any point in the future. Let's see. I just saw Rob Hurt join. Give it one more minute, you think, Jim?
I would say that at the most.
All right.
And I guess what I'll do is I'll start.
Yeah, go ahead.
Since Brett Connell will be speaking here today, I'm Jim Parham with Trude Environmental Solutions, and we'll be talking about this Hurricane Creek project. Rebecca Bearden's here also, who's a collaborator on this, and she'll be able to give a different perspective of some of the work that's been going on, which will be excellent to hear. And thank you all for joining. I'm basically filling 1 minute here for you as we get ready to start. But the project was a very interesting project located in Alabama, focused on abandoned mines and acid mine drainage. So Brett will cover this, and then we'll be available for questions after. I'll monitor the question and answer and the chat. So either place you can ask questions. We'll hold questions until the end of the presentation, just so it doesn't end up taking us forever to get through this. And the presentation's approximately half an hour long, so we should have plenty of time for questions afterwards. And feel free to put them in there, and I'll be monitoring that side of it. And with that, Brett, would you like to introduce yourself and start?
Yes, absolutely. Thanks for the introduction. My name is Brett Connell with Trude Environmental Solutions. People keep joining, so thanks for adding those people in, Jim. I appreciate that.
I'll take
And
care.
so I'm a, I guess, director of sales, and I also call myself a lead field. And either way, this project right here, been talking about it quite a bit, and being able to share the results as far as prioritizations and all the partners involved. I'm very happy to share all this, and I will just go ahead and jump right in. And so first and foremost is a big thank you. Coaco RC&D, Kelly Johnston was not able to join us today. We have Rebecca Bearden, who's with the Geological Survey of Alabama. Both her and Kelly were pinnacle as far as writing this grant. And just to kind of explain the mechanism, it was an abandoned mineland economic revitalization grant headed by Coaco RC&D, and they had partners with GSA and University of Alabama and Truda. And so they submitted this grant application to the Alabama Department of Workforce, used to be Department of Labor, but either way, that's who administers the funds for the abandoned mineland economic revitalization provided by the Office of Surface Mining and Reclamation, just to kind of show the chain of relationships between everybody in this project specifically. And to kind of go in a little bit more into this project and how it was funded, there's three major parts. The first part were some already known dangerous area. These are also priority 1 locations, which actually the reclaiming 700 feet of dangerous high wall that's considered priority 1, which definitely helped get this project funded. And then some of the other parts were pre and post construction monitoring. That's going to be Rebecca Bearden has a few slides at the end of this presentation, and she'll be able to give some more information as far as the more in-depth water quality measurements at specific locations in the watershed. And then where we come in is developing the baseline data for the entire Hurricane Creek watershed. And so that's where Kelly and Rebecca came to me, and we started assembling this project. And so we'll jump right into it. And to start the summary for high definition stream survey, the whole point of high definition stream survey is to fill in the data gaps between traditional sampling and landscape modeling up at the top. Both, Jim is a PhD in fisheries. Him and I have surveyed many streams for fish specifically, but there's always a habitat component that's involved with it. And I'm sure many people here listening have stretched a tape across the river, done a pebble count, looked at a very small section of river very in-depthly and gotten a bunch of great information, but then you take that data and you extrapolate it upstream and downstream. And so there's also the other part of that which is landscape modeling, where you can model the entire United States as, from a watershed perspective, but you might not get that meter resolution as far as doing a continuous type survey. And so that was kind of the questions that we wanted to answer. The first part, getting a rapid inventory and assessment of being able to survey 20 miles in a day, and then understanding what are the problems, where are the problems, and just how bad are they. And so understanding all of that, and then adding to that is, after you document everything and find those problems, we need to be able to monitor at a very fine scale to kind of show, it shows return on investment. If we're spending money on reclamation and restoration, we should know not only was it effective or not, but how effective was it, and how far downstream are those positive effects happening. And so this goes back to 2011, me in grad school with my advisor, Dr. Ayers, right there in the water. And back then it was just 2 cameras pointing left and right, where we did a bank erosion hazard index, which is Dave Rosgen's classic bank erosion susceptibility. And so that's been peer reviewed, published, and ever since then, Jim and I have been working, adding all sorts of different sensors and types of data that we can collect while surveying. And so we have forward video, we have underwater video, getting substrate type and embeddedness. When depth and turbidity don't allow, we're able to use the side scan sonar, which that technology just keeps getting better and better. If there's ever discharge measurements that are needed, a lot of the FERC licensing, the Federal Energy Regulatory Commission, if discharge measurements are needed, we are able to get those running in ADCP. And then we'll also run our water quality sensor, and that is very modular, if you will. We're not beholden to any one brand of water quality sensor, and we can touch on that later. And then water grab samples. And so most recently for Birmingham Waterworks Board, we took additional water quality samples at major tributaries on the Mulberry Fork. You can do water quality samples, you could do eDNA, and you could also even do soil samples if that type of georeference data would be needed. Again, the whole point of this is to georeference everything. Like, we have the technology, just turn on video cameras, externally power, and run them for 9 hours a day, and we just cover 20 miles in a day, and then we're able to turn that into meter resolution data, and we'll kind of get more and more into that. And so here we are on Hurricane Creek. You can see left, right, forward. There's no underwater video on this. It was not part of the project. And then up to the right, you can see depth imagery. The side scan sonar imagery is not shown on here. The shallow water, when you're only in a foot depth of water, the visuals from side scan sonar aren't all that great, but it's still an extremely powerful tool when visibility is not accessible on the bigger rivers and more turbid water. Then you have your satellite imagery, and water quality data is not being shown right here. The platforms for this project, we used both the backpack and the kayak. We have the inflatable boat whenever we're running underneath hydro power or bigger rivers. Then we have tablets, drones, autonomous boat, and the whole point is from the very top of the ridge all the way down to coral reefs, which we've documented in Hawaii and some of the work we've done there. But being able to have one continuous track log of latitude, longitude, the GPS information, and then surface water elevation and everything else that we continue to build into that database. So I do not know what's going on with that. Weird. And I just froze up. Sorry about that. Are you guys still able to see my calendar right now?
Yes, I can see your calendar, so
That's weird. Sorry about that. All right. One little malfunction. So right here, the first part of the deliverable that we send in any typical project is that stream view video. All of the metadata is embedded in this video. So whether you're using ArcGIS or QGIS, you can load it up into that software and you're able to see your track log, and you're able to click anywhere on that track log and start watching video from where you see it. This is a project we did for the National Park Service on the Chattahoochee River. And here you can see it's very easy to just click anywhere on a track log and be moved to that area if you want to see something specific going on in that specific stream segment. Getting back to Hurricane Creek, these polygons that you see up there, those are known as pads, problem area descriptions, and most all abandoned mine land areas have these already, where there's known problems. And so they know that there's problems in these specific watersheds from past mining practices, but they don't necessarily know, which specific tributary or even where within that tributary are the most, impactful points of pollution. Like where are those areas? And so one, we need to prioritize the pads and then also find out where within the pad those problems are coming from. And so the first part of doing this whole watershed assessment that we did in Hurricane Creek was landowner notification. It always comes up, people asking, what do you do about private property? Well, in this instance, where there's a lot of backpack, we sent mailers to, almost 1,200 people that had property adjacent to any of the tributaries that we might be going on. We sent those out. We got a few people that replied to, stay off of their property, which we willingly did. And then right here, here's the overhead map of everywhere that we surveyed within the Hurricane Creek watershed. All the pink tributaries, if you're wondering, those are actually turned out to be dry tributaries, and then all the red ones are actually where property owners told us to not go on their property. So we went ahead and did that, and we'll just keep on going. There's in total 250 miles. There's 240 major confluences, and we ended up getting close to 800 individual water quality sites. Some real quick intro for the stream corridor assessment that we applied to this whole watershed. It's also known as the SCA. It's very common. We are not beholden to this method. If somebody here is from a different state or they want to apply a different index, we're able to apply pretty much any index out there to this video and data that's collected during a high definition stream survey. But for the stream corridor assessment, there's 4 major parts. The first part is we document both riparian zones and score those. We document both stream banks, the stream bed, and then we tie it all together with discrete features that we're documenting. And that can be anything from trash to cattle to fish barriers, bridges, outfalls. That list goes on. And right here is the Hurricane Creek watershed after we did our stream corridor assessment on all of the video data. It's a whole lot of data, but with GIS, it's very easy to focus in on exactly what you want. And so we're just going to go ahead and zoom in on this area. And you can see both riparians, both stream banks, and the stream bed. Everything is associated with a date and time. So all that information that's within the video, we're able to pull it up, and you can see the individual time and video track log that it's on. And we'll just go ahead and visit there. And so here you can see tires embedded within the roots, just some very heavy stormwater impacts and size streams. You can see the riprap that they've placed there before, trying to slow down this process that's going on. You can see the exposed infrastructure and the mass amounts of erosion that have happened. And so while this project was funded for acid mine drainage and, applying the data to those problems, because we turned on our equipment, we document all the problems. And so here's just a good example of seeing stormwater impacts from the overall project. With it being GIS, you're able to cut this up many, many different ways. And so looking at it from the entire watershed perspective, just how does both riparians, stream banks, and the stream bed, how do those score amongst each other? Then we can start comparing those within sub-watersheds. And then going even further, we'll go ahead and break it up into the individual pads that the Alabama Division of Workforce was already dealing with. And so right here, we can start prioritizing how does the stream corridor assessment between all of these different problem area descriptions score against each other. And so just on the stream corridor level, we're able to start prioritizing where do we want to focus our efforts. Some of the discrete points that we were documenting, there's over 7,000, and we'll kind of get in more into what types of that point information we saw. There's a lot of acid mine drainage. There was perched culverts. There was trash piles. If you guys can see, that's me wearing an orange shirt down here at the bottom. We're still not sure. I don't know. It might be a radio tower that got twisted up during a tornado, but either way, we have that exact GPS location, and it is a giant hazard of it was quite dangerous trying to get around it, but there was a stream flowing directly underneath that pile of trash. And kind of going more into those point samples, point locations, we'll just look at just infrastructure. Because again, this was done for acid mine drainage, but somebody might want to know, well, what types of infrastructure, whether it's mining related or it's road related, water, drinking water, wastewater. And so we can start zooming in, and we'll just go right here. Well, here's some infrastructure that we saw. And you can see the massive amounts of wasting going on. You can see the old culverts that used to be buried. You can see the road that's fallen in. You can see other infrastructure, whether it's electrical, plumbing, all sorts of stuff is just sitting at the bottom. And so again, while this was a acid mine drainage focused survey, we're documenting all sorts of issues. And this is obviously a very big, is having a very big impact on the water quality downstream, because that's just massive amounts of sediment getting flushed out year after year. And just a very good description. So we know right where this is happening. We know how bad it is. And then we also, because we surveyed downstream, you can actually document, how bad is embeddedness in the substrate types downstream of there, and see how bad that, just all that sediment getting flushed downstream. Some other points, whether we're doing a stream bank restoration to repair a culvert and a blown out road, well, sometimes you might just have volunteer groups that want to go do a litter pickup, or maybe even like a willow planting. But for the case of a trash pickup, well, let's send people to the areas where they can have the biggest impact. Like, where is the most trash? And so right here, this is the area of worst trash that we saw in the Hurricane Creek watershed. So we can prioritize where they can focus their efforts. We know what it looked like on May 4th, 2023. And then considering the massive amounts of trash, this is an active dump site. So it might take more than volunteer groups, and we might actually have to get law enforcement involved to address this problem of active dumping into the Hurricane Creek watershed. The next level of prioritization that we did for stream channel modification was the iron oxidizing bacteria. And that's just the brown water, for lack of better terms. You can see right here, zooming in, we just did zero impact, moderate impact, and then highly impacted, just 3 different class levels. And so we'll go ahead and zoom in on one of these bad areas, and you can see there's some inside stream banks, but there's also just a very high colored, bright orange color, and a whole bunch of sediment sitting on the bottom of this tributary right here. And again, one beauty of having video, we have this reviewable video archive. I'm down here in Panama City, Florida, and I know we have people all across the US in this webinar right now. And so we're all able to see what are the conditions on this tributary in the North Fork Hurricane Creek. And we'll have that indefinitely. The next part of prioritization, we did water quality assessments at every single confluence. And so just typically as we're going up any watershed, whether it's Hurricane Creek or a watershed that you all work in, as we're coming up from the main channel at the bottom, I'll go ahead and take a water quality measurement in the tributary, and then another one in the main channel, and I'll keep moving my way forward. And when there's other bigger sub watersheds where sampling needs to continue, that's where a second crew would come in, and they would start picking up from there and sampling, doing the stream corridor assessment as well as the water quality sampling at every tributary. And just throughout the day, we just network our way throughout the entire watershed. And so the 250 miles ended up taking 3.5 weeks, and we had crews of 2 to 3 crews running every single day for 3.5 weeks, and got that information. Right here is the GPS locations of all those different water quality samples. We knew that we were going to be taking them at the individual major tributary as well as the main channel. There were also many unnamed tributaries that we ended up getting samples from. And then we also, anytime there's an acid mine drainage coming into that tributary, we'd be able to get a sample downstream and upstream, so you can start, looking at how big of an impact was this individual seep having on the tributary as a whole. There's a lot of beautiful water. Hurricane Creek is an absolutely gorgeous watershed. There's just some parts of it where there's acid mine drainage and discoloring the water to a pretty large extent. The next part, just looking a little bit closer to the water quality, the majority of them were right around neutral, but you have these outliers right here of some very acidic water. And having the measurements is one thing, having the GPS location is another, and we can see it's very correlated. All those all the water quality locations within the pads definitely, or all the highest ones are within the pads, and the lowest measurement we actually got was 3.17, which is very acidic. And so that way we're able to, start prioritizing by the pads just with pH. And we ended up going a little bit further rather than prioritizing just by SCA or just water quality or the different points. We're looking at everything. And so there's a couple levels to this. One, because we documented baseline conditions throughout this whole watershed, we're able to see, reclamation's been done in this watershed since, the 80s that projects have been going in. And so we can start looking at past reclamation and start seeing, which types of reclamation were having bigger benefits. Which one, were we able to spend less on one type and get a bigger impact? Well, we probably want to repeat successful ones. And if something was not as effective, we can start, maybe not doing that one as much. And so we're able to compare past reclamation. We've prioritized, we've identified and prioritized where future restoration should most likely happen if you want to, invest the least amount of money and have the biggest bang for your buck, and just that whole prioritization of future restoration. And then we'll also be able to go back and compare with meter resolution. The 4 parts that the Department of Labor, Department of Workforce wanted us to prioritize by was the stream corridor assessment. So that's just looking at the overall functionality of the stream. Then you have your point impacts that kind of sums up all the individual point impacts, whether it's acid mine drainage, trash, cattle, outfalls, how bad was that outfall? So that kind of takes in all the different point information. We added in the iron oxidizing bacteria, as far as, the color of that stream and how bad was it. Then the final part was water quality pH. The iron oxidizing bacteria and pH were pretty correlated, not exactly, but either way, we took those 4 prioritizations, put them together, and this is their, unweighted overall prioritization based on those 4 metrics that we delivered to the Department of Workforce. And so Kelly Johnson with Coaco and Rebecca Bearden at the Geological Survey of Alabama will be basing future restoration on this. And then just go ahead and go to the conclusions for this project. We knocked out 250 miles. We had, 2 to 3 crews running every single day, did it in 3.5 weeks. We created that 1 meter resolution continuous baseline survey, that whole inventory of the whole watershed. And then we had, with that data, we were able to prioritize individual stream segments and where within those were the most impacted by acid mine drainage, but also identified and prioritized areas based on stormwater damage or even infrastructure, and then other types of impacts that were happening to the watershed. So there's just numerous different levels of prioritization that we're able to do with this data. And just to kind of say one more time what was delivered, we have the stream view video to pretty much give everybody the ability to tour a watershed without having to assemble a field crew and look at weather and look at flows and make sure that it's going to be suitable. We deliver that GIS data that's actually embedded in the video, and then we have a very detailed report. This report for Hurricane Creek is available, and we should be able to send that out to anybody interested in seeing a very, very dense, big report that'll take some time to go through, but we're very proud of that report. And just to kind of reiterate one time, the integrated planning framework of high definition stream survey. And one, we have a very diverse group of people here right now, so it's perfect to hit on this. And then also just with the current federal funding climate where everybody needs data and we have less money. And so we need to start, one, I think, forming better partnerships, but also using better data. If we can have one survey, such as high definition stream survey, and that data can be applied to stormwater, the data can be applied to infrastructure, water quantity, water quality, whether we're dealing with hydropower, that data can be applied to fisheries and wildlife, whether you're dealing with darters, mussels, sturgeon, it doesn't matter. We can take all this information and apply it to the wildlife. And then one of my favorites is we all, we're water resource professionals in here, the majority of us, I assume, but there's also a lot of people who care about the watershed and care about the water that their kids fish and swim and even eat from. And they care about it, even though they might not know much about it. And so being able to, one, show red is bad, green is good, yellow is in the middle, just make it very easy to understand what parts of the river are good, what parts are bad. And then being able to take them on a field trip without actually having to go in the field and show them what are the conditions of the river at that area, whether it's good or bad. And so just the transparency between river managers and stakeholders, where everybody wants cleaner water for the benefit of humans living there. And I'll go ahead and end my segment right there. We'll get to questions right after, but Rebecca Bearden is gonna join in right now and talk about some of the more specific water quality samples that she was collecting with the Geological Survey of Alabama and the University of Alabama. But Rebecca, can you hear me?
I can, yes. Thank you, Brett. Can you guys hear me?
I can hear you.
You're good. Thank you so much. That was an awesome presentation, and kind of to follow up with what Brett was saying, moving from that large watershed scale down to a more targeted area is what our part of this project entailed. So the reclamation that was set for this roughly 70 acre plot for the high wall restoration, we looked at the retention pond that was previously put in place as part of an earlier reclamation, and then the stream surrounding that. So the water that basically flowed from the high wall to the pond, and then from the pond to the receiving streams. So that's what you're looking at here in this very simple graphic, because we do very simple things. We find that works really well. So you can see the retention pond there with a little blue circle. So our sites that we set for sampling included both the retention pond as well as the stream that the pond flowed into, which you can kind of follow. It flows from north to south. That's Jimmy Creek. Jimmy with one M. We love Alabama stream naming. So Jimmy Creek proper. And then from sites 8, 9, and 10, you can see that flows into site 7, site 4. Apologies for the awkward naming. We worked with grad students and others on these projects, and so it was at their discretion for how they named their sites and how they numbered their sites. So just to give you a general idea there of the sites and where they're located. So 8, 9, and 10 being very heavily influenced by that retention pond, and then 7, 4, and 6, and the others more of a mainstream target area for us to see what were the effects of the current situation from, like, what does it look like, when the water's flowing from that pond into the mainstream. What is the pH? What is the conductivity? What are some of those physiochemical parameters? But also in a more in-depth scale, kind of taking what Brett does to the next level, we did geochemistry, and we looked at specific heavy metals that are associated with acid mine drainage, and typically with abandoned mine land sites. So those were, that's basically an overview of the sites we sampled, and the parameters that we looked at are going to be those that are normally associated with water quality, so ecological health, environmental health, but also with that heavy metal analysis to give us an idea of where are the pinpoints and sort of the pain points in this system for heavy metals, and how is that acid mine drainage affecting not only the direct site, but also sites downstream of the remediation site. So this was all pre-reclamation. Obviously, we're looking forward to doing post-reclamation when everything happens for that part of the project. So we had 10 sites that you can see here. We're going to go ahead. We looked at both surface water and sediment. We did sediment analysis as well as surface water. And we did that basically every month for about 4 years. So we have a really solid data set pre-reclamation. So we can't wait to compare that to our post-reclamation data when that goes down. Right, if you'll cruise to the next slide. Thank you. So here are our results. And just kind of keep in mind those locations that I mentioned in that first slide. So the main contributors, or the main sort of like indicators of acid mine drainage as far as metals are concerned, is aluminum and iron, manganese, and nickel. So we looked at aluminum, iron, manganese, and nickel throughout time. This shows a 3-year period there from 2022 to 2024. So if you look at that left plot, you'll see we've got them grouped. So group 1 is surface water 1 through surface water 6 there. So sites 1 through 6 were just the streams themselves that received the acid mine runoff, but not necessarily directly at the retention pond. Site 7, same kind of thing. It was actually upstream of the pond. So it was a site that we sort of used as a control just to see, what were conditions like upstream of the retention pond. And then sites 8, 9, and 10 were at the pond proper. So site 8 actually drained the pond, and then sites 9 and 10 were in the pond. So that gives you that visual spatial setup there. So you'll notice in sites 8, 9, and 10, those parameters, specifically manganese, was highly elevated, like, so to the point of being crazy. So that's just classic like AML, like you expect that, you know, in your retention pond for acid mine drainage. And that means that the pond's doing what it's supposed to do, right? So everything draining off that high wall is going into that retention pond. So you're seeing these elevated metals. So, you know, that's sort of a no-brainer, a no-duh, of course. Of course, we've got elevated manganese, we've got elevated aluminum, and elevated iron in those sites. Well, interestingly enough, the site above, the reclamation, didn't really show a whole lot of AML or acid mine issues there. And it was somewhat mitigated further downstream in sites 1 through 6. So you're seeing somewhat of a buffering or a tempering, so to speak, of the heavy metals, so that clearly the retention pond is doing its job, and that before that water reaches, or once that water leaves the pond at site 8 and gets into the mainstream in sites 1 through 6, a lot of these heavy metals we're not picking up in our water sampling. So all that's good news. Having said that, that area, as Brett showed everyone on those slides, is very influenced all around by abandoned mine land areas. And so a lot of this, you may see results and you're like, well, we're getting a little noise from X, Y, or Z, or places upstream. And that's what you're going to see. You know, these attempts to do reclamation, you can only do one at a time, and you usually work upstream to downstream. And so having that setup, you just know that your data downstream may show an influence of an acid mine site, and it might not be related to that reclamation you did upstream. It might be related to a reclamation that still needs to take place downstream. So you kind of have to keep your spatial awareness when it comes to these types of things, and also to data interpretation as well. So that plot on the right essentially shows very elevated, well, it shows pretty normal pH. I know it's a little awkward to read, but the pH levels, those are the box plots, right? So if we're just looking at the box plots, you're seeing pH be pretty normal. You're in that 6 to 8 range for the majority of our sites, 1 through 7, the streams. But if you look at 8, 9, and 10, that's where the retention pond is, you'll see that pH be a lot lower. And it was normally in the 3 to 4 range when we did our sampling, which again shows that, hey, that's, you know, that's acid mine. We knew that was going to be the case. This is another representation of the elevated metals here, and gives you an idea throughout time of what those looks like at the sites as a whole. So again, very elevated manganese at the retention pond sites, and less elevated at our other stream sites. I'm going to the next slide, Brett. So this is our last one. I'll try not to bore you with too much science, but a little bit of a nerd, so just bear with me. So this one is a cool plot there. We'll look at the one on the left to start with, and it shows conductivity. Conductivity, if you're familiar with it, is basically the amount of dissolved things. I'll be real simple, Reader's Digest version, all the little dissolved things, minerals and whatnot in the water. It also gives you a measure of how well it can conduct electricity, so hence the conductivity. So if you got a lot of dissolved things in the water, your conductivity levels are going to be high. And as you can see in sites where we had an abandoned mine land or acid mine drainage situation, those conductivity levels were elevated. So that's your red line on those plots. And you can see for sites 8 through 10 in group 3, a lot higher conductivity than site number 7, which is kind of our little control site. And then from sites 1 through 6, you notice a weird, like, well, what's the story on that one? Why is it high some of the year and low other times of the year? Well, we see a lot of temporal or seasonal effects on these water quality parameters, and conductivity is one of them. So you can imagine during high flow versus low flow, like what time of the year do you think we got a whole bunch of water coming through the system? That's normally going to be springtime, right? Depending on the rain, versus fall, when you've got a lot more base flow contribution from groundwater. So you got groundwater coming in. It's kind of the only source for the surface water for it to be any water, right? And the surface water is from the groundwater. So you're going to have different conductivity levels because your volume of water is completely different in different times of the year. So that's explaining that conductivity chloride relationship there, which is what we used as one of our indicators there. So all that to say, it looks like, as you can see from sites 1 through 6, like I mentioned earlier, you're like, okay, well, that's still a pretty elevated conductivity level, nowhere near what it is at 8 through 10, but still elevated compared to, you know, some of the other places that you would sample. And that basically gives you an idea of, okay, some of these others may have like an abandoned mine land or acid mine drainage coming in from some other place, not necessarily from the target reclamation site, but from other places that that's just part of the story in this neck of the woods. So a lot of this data just take with the, you know, in a big interpretation of what's going on across the landscape. So the second plot there, basically looking at major elements through time. Again, that's taken some of our different ones. We're looking at calcium, potassium, magnesium, and sodium. And you'll notice that, of course, our stream sections, okay, we've got a whole lot more in sites 1 through 6, a lot more elevated levels there. And this, the calcium, magnesium, potassium, this is sort of like the flip. So it's like the reverse of what you would see at an acid mine site. Is what you're going to have for calcium, magnesium, potassium. So you're looking at the flip side, basically. So all those heavy metals that we saw super elevated in that other slide, you're seeing these other elements elevated in this slide, because this is typically what's going to be your background scenario for reference streams. So of course, they're going to be higher in sites where we don't have an AML, as much of an AML influence, and much lower over there for 8 through 10, where you've got more of an AML influence. So that's just another way to look at this data using heavy metals and also using our major elements or ions that we typically sample for. That sort of the take home there is that this data set just basically shows a very good example of, here's the retention pond doing its job. We're seeing a lot of acid mine classic signature heavy metals and what normally you would say low pH are right there at that retention pond. However, once that pond, once that water leaves the pond, goes into the stream, you definitely notice that it has been buffered. And by the time it gets to the stream, lower pHs, closer to 7, and much lower heavy metal concentrations. So that's sort of our cool take-home message there, is that it appears that once that water leaves the drainage pond, it's definitely being buffered by Mother Nature or otherwise. We don't know. There might be some anthropogenic inputs there in between the two from where the pond meets the stream, but it's definitely being buffered so that by the time it reaches the stream, you're not seeing as much of an influence. However, downstream, because you've got other sites kind of coming in, some of that's picking back up, and you're seeing higher conductivity levels in different places up and downstream because of other AML influences. So like everything, it's complicated, but all this to say, the reclamation will be such a huge benefit for this part of the watershed, because once you start working little by little, which is what the Department of Workforce can do with what its time and resources have, to be able to target these sites like this that we know are in immediate need of reclamation and restoration, that helps. And so the ability to be able to prioritize these sites using those tools that Brett provided then helps us with that follow-up, so we can really show with hard data, here's what it was before and here's what it is after. So I'll turn it back over to Brett.
That's awesome. Thank you very much for sharing all that information. And yeah, it will be great to see just as time goes on, the more data you collect within this watershed, and then us getting back out there, it'll just be great to see like how everything changes with all the reclamation that you guys have going in there. So it's great to see all that information. Let's see. That's the end of the presentation for us. Again, Rebecca, thank you so much for contributing to that. That means a lot. So thank you very much. But this will be, I don't know, Jim, have any questions been popping up in the Q&A or in the comment section?
I don't see any questions yet. Does anybody have any questions for Brett or Rebecca on this project? You're obviously welcome to raise your hand. I think we can see that. Chime in or write into the chat or Q&A, I guess it is. So Amanda Pitzer, thanks for joining, Amanda. Amanda Pitzer works for the Cheat River, Friends of the Cheat, up in West Virginia, and she asked, was flow data collected to be able to produce pollutant loadings?
We did collect discharge. Yeah, for each time we did a water quality sample, we do have stream discharge to accompany those results, just to make sure that we're interpreting them in terms of the stream flow. Yes, we're not producing any specific loading outputs, but we are using the stream flow to interpret the results of our water quality set.
Good deal. Yeah, and so to be a little bit even more specific on that, like Rebecca is heading the water quality sampling that includes the discharge measurements, where when we did our survey, there was no discharge measurements collected. But Amanda, right in your neck of the woods, we actually have a proposal submitted right now on Greens Run within the Cheat River watershed to actually do our high definition stream survey as well as collect discharge measurements. So I was still waiting to let you know about that, but I really appreciate you joining and thanks for the question. And I totally understand about having a kiddo and not turning on the mic, so totally fine. But thank you for the question. And anybody else, yeah, whether you write down the message in the comments or use the Q&A or just raise your hand or start speaking, we'll be able to, we've stayed on here for over an hour before to answer questions, so we'll be more than happy. And Rebecca, if you have something else to do, I mean, either way, if you needed to take off, don't leave everything up to you.
Thank you, Brett. Well, I appreciate you guys having me. Thank you so much for letting me speak.
100%. All right, Amanda, thank you.
I'll chime in for a second while we don't have questions coming in. And one of the strengths, and it probably doesn't show in this project, of the high definition stream survey approach is the information that you're seeing here. The majority of it is not sort of classified in the field. So we collect all the data, and much of the classification is post-processing. So I've done many projects for many, many years, and we used to have data sheets that we would go out and we would have to determine all the questions in advance and put little things down, and then we'd go out and check off whether we see something or not. And then you return back to the lab, and a couple of years later, someone asks, well, did you guys look for this while you were out there? And you'd say, well, not really. It wasn't on my data sheet, or I saw it, but I don't remember where it was. And so one of the huge strengths of this approach is that doesn't happen. And we've had projects where after the project goes, Brett already caught me on this one. Here's the Upper Delaware River, where after a survey, we're looking at trout habitat and a bunch of other things. That pretty bush on the side where it's all in bloom is Japanese knotweed. And that's a highly invasive kind of bamboo-like plant that is now on the stream banks all over this area, and probably many people in the Northeast will recognize it as a major problem. Well, I had never seen Japanese knotweed before, and Brett and I are going down the river, and we're like, this is a beautiful river with gorgeous habitat and gorgeous trout and beautiful plants on the shore. Afterwards, we were asked a couple months afterwards, well, did you guys see Japanese knotweed, and are you able to identify it? Well, yes, we are able to identify it, and afterwards we were shown what it was. We're able to go through and with sort of meter scale resolution on both banks identify it. So in this case, it was an invasive plant that was not the focus of our survey. You may have another slide following this one up, Brett. In terms of sort of the output, over on the left-hand side, the red area is where Japanese knotweed is present, and the green area is where it's absent. So with meter resolution, we can look through the whole watershed and see where that is. Now, this is the beauty of not doing all the classifications in the field, because again, this was not the intent of the survey, but it was an easy additional classification of the data. We're able to go down and show the per meter per bank, whether it's presence or absence. And basically I can see now why they're considering this a problem when 45% of the total stream banks are covered in knotweed. And that's a pretty huge amount, in the context of what's going on in that area. So they now also have all kinds of different science projects aimed at controlling knotweed, and we're able to look at the conditions here. And as those projects are implemented and looked at, they're able to see, is this actually having any change to the system? So this is a different take on the data we saw here. I think Brett sort of alluded to the fact that we saw stormwater damage, we saw infrastructure damage, we saw trash, we saw a lot of impacts from forestry practices, all kinds of different things like that in the watershed. And then we also saw the specific target issues of acid mine drainage and abandoned mine land issues throughout there. So it's kind of a really nice way to collect data without restricting yourself to your specific topic at hand.
Good deal. Thank you for that clarification. And we have, obviously we have over 1,400 miles of river across the US and projects done for all different types of purposes. So if you guys, whether you wanted to ask a question on abandoned mine lands, or if you had another question more specific to fisheries or anything else, we'd be more than happy to pull up a slide and discuss any questions that you might have.
And if not, thank you absolutely for your time. We'll be happy to talk with you guys at another time. We are doing projects all over the country right now for a whole number of different issues. And this abandoned mine land is a very important topic, and trying to figure out the impacts of the legacy mining. So things prior to the 1970s is a difficult question on trying to make sure we have healthy water throughout a watershed. So if you don't have anything else, Brett, and there are no further questions, thank you very much for your time.
Yep. Thank you everybody for joining. And good deal. Thanks for all the comments. I think if anything, the last parting comment I want to say is I know federal funding, everybody's, federal employees and everybody's kind of walking on eggshells, and it obviously is a little bit uncertain right now. We have proposals on hold, and so we're, in the same boat as some of the people. But either way, looking forward specifically to high definition stream survey, and actually it relates to everybody, is we need to start making better decisions and more efficient decisions. And that's literally where I just see, and obviously I'm champion of high definition stream survey. I see it being extremely valuable to helping form partnerships. The more organizations and partnerships that we can have working together to reduce the amount of redundant information that gets collected, to increase transparency and increase efficiency within that watershed, bringing together NGOs, federal, state organizations, even consultants, like having one method that everybody can use for different water resource purposes. I just see us being extremely valuable, this being an extremely valuable tool for all of you to, do your jobs better. And, the whole point of us doing what we do is to improve the environment and to make sure development is done responsibly, finding that balance between using it properly and abusing it. And the only way to do that is to have large amounts of data sets where you can't skew the data because you have so much of it. And so either way, I'm very optimistic moving forward, and I know that high definition stream survey will be a valuable tool for everybody. So again, I really thank everybody for sticking around, listening to me, and joining the presentation. I will be sending out another email to everybody with the recording to our YouTube. Like, this will be uploaded to our YouTube channel, and I'll make sure you all have access to this. So you'll be more than happy to. I'd love for you to share it with anybody you want. And either way, I really appreciate everybody for joining. So thank you again. And looks like there's some comments rolling in.
It's mostly thank yous.
All right, well, sweet.
Okay.
Thank you, everybody. And again, we'll be keeping in touch. You have a great day. Have a great weekend.
Thanks. Bye-bye.
Bye.